Hello, in this one, let's take a look at showing that 1 divided by r e to the I theta is equal to 1 over r times e to the negative I theta. So how can we show that? We can proceed as follows. Remember the following, that e to the I theta in its context of complex numbers can be defined as cosine theta plus I sine theta. That means that to form the conjugate of this quantity, I will do the following. I would replace theta with negative theta. Now, why would I do that? So above my head, it says e to the negative I theta. When you put that into the cosine and sine, it would be cosine of negative theta plus I sine of negative theta at step 2b. Think about this. The cosine of theta is an even function, which means even when you put something negative in there, what comes out is the same thing as the original, meaning cosine theta. But the sine function is odd, which means when you put a negative theta in there, what comes out is a negative between the two terms. And then the angle back there over here is positive now, you see? So you place that in the middle. But what does that show us? What it shows is the following, that back at step A, you had a positive. That was cosine theta plus I sine theta. That was, in other words, e to the I theta. Over here at 2c, what you have is cosine theta minus I sine theta. You have a negative. That means it's a complex conjugate. But remember where this comes from. This comes from this expression above my head, e to the negative I theta. So all of that is just explaining how to form the complex conjugate of e to the I theta. We need that for the following reason. Take this expression at step 3 where it says 1 over r e to the I theta and multiply by the ratio of its complex conjugates. So it's going to be e to the negative I theta divided by e to the negative I theta. We're going to get rid of the I theta part in the bottom. So take a look at the next step. So step 3b, you're going to do back at step A, or 3a rather, 1 times e to the negative I theta. So at step 3b, the numerator is e to the I theta divided by r times e to the I theta minus I theta. That's because at step 3a back here, you see you have I theta, then you have negative I theta. So you keep the base e, and then you just add up the exponents, and that's all it is. Basic properties, in other words. Then you simplify. So at step 3c, e to the I theta stays. But here below me, you have r times e to the 0 now. The 0 is the result of doing I theta minus I theta back at step 3b. Above my head. I hope you see that. That's going to give you e to the 0, but of course e to the 0 is just a number 1. So at step 3d, you're going to have r in the bottom and nothing else. And at the top, the whole time, you have e to the I theta negative. And a common way of writing the expression at step 3d is to take that r and place it at front as 1 over r, its fraction form, and then copy the exponential part as e to the negative I theta, like that. So all of this is just simply showing the following, that down below, I have that 1 divided by r e to the I theta is equal to 1 over r times e to the negative I theta, and that's it. So that's it for this one. Thanks so much for watching. Leave a like and subscribe. I'll see you in another video.